Okay, so now I will be going over question 33. So the first concept I will go over for question 33 is simple harmonic motion. Okay, so simple harmonic motion is an oscillatory motion, and it is where the net force of the system is basically a restoring force. In terms of this problem, we are going to be talking about simple harmonic motion for a spring. There's also we can also do simple harmonic motion for a pendulum, but in terms of this problem, it's just going to be a spring. So that is what I'm going to do. So basically for a spring, the spring is responsible for the oscillation. And the equation we use for that is that force is equal to negative kx. So that's what we use for it. So now I'm going to show basically for simple harmonic motion for a spring, where acceleration, velocity, and displacement are for it, using diagrams. So the first one I'm going to show is when an object is in equilibrium. So here, and then I'm just going to go like this. Basically this is x equals 0, and so right here, it's here that the object is in equilibrium, and when it's in equilibrium, the velocity is at a maximum, and then the acceleration is at 0, and the restoring force is at 0 too, and that makes sense. Okay, so when an object is here, the velocity will be 0, because it will be at 0, and then the acceleration will be pointed this way. In this one, so x is equal to the acceleration, and it will be positive this way, and then the restoring force will be this way. And then lastly, we'll do here, just trying to show it. On the other end, acceleration will be going this way, velocity will be 0, and we will have the x equal to the negative acceleration. Okay, so just trying to show the basic parts of simple harmonic motion. Okay, so now I will read the question. An object is initially hanging in equilibrium from a vertical spring. The object is pulled down 15 centimeters from its equilibrium position, as illustrated above, and released at time equals 0. The object then oscillates with a period of 2 seconds. Let x equal 0 be the equilibrium position, and let the positive direction be upward. What is the position of the object at time equals 3 seconds? Okay, so first I'm just going to draw what's happening in this problem just to make it simpler. So there is an object here, and it starts at the bottom, and then we release it, and it goes up and down like that. So here, x is equal to 0. This is at equilibrium. So let's do EQ for equilibrium. This is x equals 15 centimeters, and it's at time equals 1 second. It says the period here is 2 seconds, so that means for it to go up and down, that's 2 seconds. So that means up here it's at 1 second, and then x equals negative 15, and this is at time equals 0 or time equals 2 seconds. Okay, so it's trying to find the position of the object at time equals 3 seconds. So in order to do that, we just need to look at how it will go after 3 seconds. So let's just basically go through this. So it starts here at time equals 0 seconds, and then at 1 second it will go up, so it will be at 15. At 2 seconds it will go back down, time equals 2 seconds, and then at 1 more second for 3 seconds it will go back up. And so that means the position at time equals 3 seconds will be 15 centimeters, which is A. And basically, we just figured that out because we know the period and we know the different positions, and so we know 1, 2, 3, it will be at 15 centimeters. So in conclusion, this video showed important concepts of simple harmonic motion, and specifically that for a spring, and how to use the period to find the position.